HFE times RE. That's my first calculation for stiffness. Stiff. Okay, HFE is how much? 150. RE is how much? What's 1.2K times 150? 180K. Ten times R2 is 10 times 4.7K, which is 47K. Is the circuit stiff? Yes. Is 180K greater than 47K? The answer is yes. Circuit is stiff. So at the bottom of page 3, I indicate that the circuit is stiff. Okay? So then, what I do is, so what that's telling me is by looking at the voltage divider circuit, this transistor appears to be a stiff circuit. So now let's go to page 4 and find the Q point. To find the Q point, I start off with, so at the top of page 4, can you write down Q point? Right at the top. VB, above VB, write down Q point analysis. First thing I do is I calculate VB. VB is the voltage at the base. And in electronics, anytime I talk about a voltage by a single letter of the alphabet, it means it's with reference to ground. Okay? So VB is base to ground. VE is emitter to ground. VC is collector to ground. You follow? When I mention voltage by a single letter of the alphabet, it means it's with reference to ground. So VB is this voltage here. Do you see that that voltage here is also the voltage R2? So is that R2 over R1 plus R2 times VCC? My voltage divider circuit. Because the circuit is stiff, I can use this equation. If the circuit is not stiff, I cannot use this equation. Go to page 5. What does the note at the top of page 5 say? What is the note at the top of page 5? Not stiff. Okay? So if the circuit is not stiff, I use the equations that are shown on page 5. But if the circuit is stiff, I use the equations on page 2. Okay? All right. So let's put some values here. R2 is what? 4.7K divided by 18K plus 4.7K times what? 10? How much? 2.7? 2.7 volts. 2.7. So VB, which is VR2, is 2.7 volts. Now that I found VB, I'll calculate VE, which is right here. VE. VB is the voltage at the base. VE is the voltage at the emitter with reference to ground. And VE is always 0.7 lower. VB minus VBE.
So on average, you're 2.07.
2.07. Okay, 2.07 it is. So let's calculate VE now. VE is 2.07 minus 0.7. VBE is the base to emitter voltage, which is the PN junction, which is always around 0.7. So what is 2.07 minus 0.7? How much? 1.37 volts. So that's VE, from the emitter to ground. Now that I found VE, the voltage here, I can calculate the current in the emitter, IE. IE is Ohm's law, VE over RE. Okay, VE is 1.37, RE is 1.2 K. How much? 1.1 milliamps. So that's the current in the emitter. IC, which is the current in the collector, is almost equal to IE. Because IE is IC plus IB, right? And IB is 150 times smaller, so we say that IE is about IC, which is 1.1 million. So the current here is 1.1 million. So, now that I found IC here, can I calculate this voltage here? That's VRC, isn't it? Let's show that at the bottom right here. In this space that you have at the bottom, let's calculate VRC.